Hello students, welcome to JCE Connect, subject Engineering Geology. In today's class, we will discuss about the structures of igneous rocks. So first let me tell you what are structures. So structures are the characteristic features that give a conspicuous appearance to the rock, that is called as its structure. A feature that will give a particular appearance to the rock, that is called as the structure. So they are classified as large scale features, and as well as they are classified into very minute microscopic features. They are called as textures. Okay, if it is microscopic, we use the word as texture, but structures are usually the large scale features or megascopic features. So the structures of igneous rocks, they are broadly classified into two types. One is primary structures and other one is secondary structures. So primary structures are those those features which are developed in igneous rocks at the time of its formation, like at the time of its cooling and consolidation of the magma or lava. During that period, whatever structures are formed, those are called as primary structures. And secondary structures are those which have been imposed upon the existing rocks after the formation of the rocks. So that these are the two different types of structures, primary and secondary structures. So the igneous rocks show variety of structures. So in that, we'll first discuss about the vesicular and amygdaloidal structure. So what is mean by vesicular and amygdaloidal structure and how they are formed? So you have seen how the magma comes out on the surface and it erupts, right? Then we call it as a lava. So most of the lavas, they are heavily charged with gases and vapors. Okay, so what happens to those gases and vapors when it comes on the surface, right? So what happens, which escape, those gases and vapors which are present in the lava, they escape as soon as the pressure is diminished by their eruption at the surface. So as soon as the lava comes on the surface, there will be diminished in the pressure will be diminished, and as a result the gases which are present, they escape from that lava. And this escape of gases in rapidly cooling lava, they leave its impression with the production of cavities. So here you can see the cavities, right? So those cavities are nothing but the cavities, or we call them as voids. Okay, so these cavities are, or voids, they are formed as a result of escape of gases from the lava. So these voids are spherical or irregular in shape, and these are also called as vesicles. Okay, and the rock containing such empty voids or vesicles, they are called as voids. Okay, voids or vesicles, these are the voids or vesicles, and the rock containing such voids is called as the structure is called as the vesicular structure. So they are empty vesicles or the voids, and if the rock contains such voids or vesicles which are empty, okay, the structure is called as the vesicular structure. Then what is mean by amygdaloidal structures? Amygdaloidal means the structure which forms in the vesicular rocks. Okay, whenever the rocks are vesicular, this amygdaloidal structure is seen in those rocks. So what is that amygdaloidal? So these vesicles, they are filled up by secondary minerals, as you can see here. Okay, this picture is from Shaniwar Wada Pune, right? And here on this rock you can see the cavities or the voids which are present, they are filled with secondary minerals. Here in this image also you can see all these cavities are not empty, they are filled with something. That something is the secondary minerals such as calcite, zeolites, silica, then hydrated ferromagnesium silicates. These all minerals, they get filled up in these vesicles, and these secondary minerals which are present in the vesicles, they resemble the shape of almond, okay, and the shape of the grains are known as amygdales, and the rock containing such structure is called as amygdaloidal structure. So here you can notice that this vesicular structure is called as primary structure because it is formed when the lava is cooling, right? So it is a primary structure, it has formed during the formation of the rock, whereas this amygdaloidal structure is a secondary structure which has formed after the formation of these vesicles. These minerals like calcite, zeolites, silica, they get filled up in those vesicles and they resemble the shape of the almond, and because of this reason they are called as amygdales, and the structure is called as amygdaloidal structure. So we'll move on to the next structure. So this structure, that is vesicular and amygdaloidal structure, is mainly it is the characteristic structure of the basaltic rock, basalt, okay, because basalt is the rock which is formed by lava. It is a common basic igneous rock which is formed by cooling and consolidation of lava. So that is formed on the surface, so we call it as extrusive igneous rock, or we also call it as volcanic igneous rock. Okay, so this is the common structure, vesicular and amygdaloidal structure shown by the basaltic rocks. Then we'll move on to the next structure which is shown by the igneous rocks, that is the blocky and ropey structure. So these are the two different appearances, okay, and they may be presented by the again lava flows. Okay, so the lava, if it is acidic in composition, that will be highly viscous, and what happens, because its viscosity is high, what happens, it cannot flow for a long distance or a greater distance. So what happens to such lava? After consolidation, the surface of the such type of lava is covered with the mass of very rough and jagged angular blocks. Here you can see in this image, okay, there are very rough irregular blocks, okay, angular blocks of all dimensions, and those are called as blocky lava, or simply it is called as AA. AA is a Hawaiian name, okay, it is characteristics of viscous lava. So when this blocky structure is seen, when the lava is very viscous in nature, viscosity is more, then what happens, it cannot flow for a greater distance. So what happens, after solidification, the surface of such lava after cooling, it is covered with some rough, very jagged and angular blocks of all dimensions, and those are known as blocky lava. Then there is one more structure which is again formed by lava, that is basic lavas, okay, which are highly mobile, okay, they are highly mobile, they can flow for a greater distance, they have the low viscosity, and because of that such lava can flow for a longer distance, okay, and for a greater distance, and they solidify with smooth surface, and they often have the highly glazed and they exhibit wrinkled or ropey or corroded form, and the surface is diversified by low domes which show the radial cracks. Such structure is called as a ropey structure. Ropey is again, it is also called as pahoho. It is again a Hawaiian word, so you can remember it as a blocky and ropey structure. So here you can see in the image, it looks like a rope. Okay, so ropey structure, here also you can see it looks like a rope. So how this is formed? The lava, which is highly mobile, very mobile, and because of that it can flow for a greater distance, and this is possible because the lava is having the low viscosity, and this type of lava, it will solidify with smooth surfaces. Okay, and they are highly glazed. Okay, and they exhibit wrinkles. Okay, so these wrinkles, they look like ropey structure. Okay, and such a structure which is shown by the rocks, they are called as ropey structure. Okay, so this is one more type of structure which is again common structure shown by the basaltic rock. Blocky and ropey structure. Next we'll move on to one more important structure which is columnar structure. So this type of rocks you can see in Malpe Island, that is in Udupi, St. Mary's Island. You might have seen there is an island wherein you can see such type of rocks which are exactly perfect columnar structures. So what is that? How it is formed? So when the magma starts cooling with the uniform cooling and contraction in the homogeneous magma, what happens? The parting planes, okay, these are parting planes which are developed. Okay, they tend to take a regular columnar or prismatic form, and they are characterized by development of either 4 or 5 or 6 sided columns, or they look like a prism, and these columns are developed perpendicular to the cooling surface. So this is the cooling surface from which, from all the sides, the lava is cooling. Okay, and this is formed perpendicular to the surface of cooling. Okay, and the columnar structure is due to development of centers of contraction. This is important. Here what happens? There will be development of centers of contraction, and towards that center what happens? And these centers will be equally spaced intervals and on the cooling surfaces, and the line which joins these centers, they are the directions of greater tensile stress, and when the rigidity of the rock is overcome, the cracks will appear, and these cracks will be perpendicular to the lines, that is the line of tensile stress, and these lines will intersect so as to enclose a hexagonal area, and they extend downward or upward from the cooling surface, and they produce this type of prismatic columns. So what happens here in columnar structure? There will be development of centers of contraction. So at equal intervals you can see the development of centers of contraction. So what happens to such centers? So towards the center point, the cooling, while cooling, the contraction takes place towards the center. So like this, at equal interval you will find the development of centers of contraction. Okay, and these are equally spaced centers of contraction, they are equally spaced intervals on the cooling surface. So this is how the columnar structures are developed perpendicular to the cooling surface. So this is again seen in the basaltic rock, which is again columnar basalt is very famous. Okay, even in some part of Maharashtra, even in Belgaum, in some areas you will find these type of columnar structures, which are very common feature of basaltic rocks. Okay, then we'll move on to the next structure, that is the pillow structure. Pillow structure, or it is also called as ellipsoidal structure. What is that pillow or ellipsoidal structure? So again, this is a peculiar structure which occurs in mainly the basic lavas. So here the lava which is present, that exhibits the appearance of a pile of small masses which have been compared to pillows. You can see there are this shape, you can just observe, it looks like round pillows. Okay, here it is exactly clearly seen. Okay, rounded pillow like structures. Okay, so these are the pillow margins, right? So how these are formed? So here the lava exhibits the appearance of a pile of small masses which have been compared to the pillows or sacks or cushions. Okay, they look like that, so the name is given as pillow structure. So these the pillows are generally, they have a vesicular crest and occasionally a glassy skin. So here this type of pillows are usually found wherein the lava comes in contact with the water, that is especially the salt water. Okay, so it frequently shows the flow banding, okay, by the lines of vesicles which are concentric with its surface and they are filled. So along its surface you or edges of the pillows, you can see there are vesicular structures. The association of such pillow lavas with marine sediments, that has led to the view that the structures are due to the contact of molten lava with the sea water. So when this type of structure is seen, when the lava which is cooling, that comes in contact with the sea water. So this is a particular structure which is observed when the lava comes in contact with the sea water. So the pillow may be connected to one another, okay, by a short tube or the neck along the sides. Okay, so this type of structures are commonly seen in again basaltic rocks. In Gadag and all areas, we have observed this type of structures which are called as pillow structure. So this is a particular structure which is again occurring in the basic lava, which is rich in soda. Okay, that is rock containing high lime, okay, soda. So here the lava exhibits the appearance of a pile of masses which have been compared with the pillows. So the name is given as pillow structure. Next common structure which is shown by again igneous rocks is xenolith structure. So what is mean by xenolith? You can see here in the image, xenolith is this part, okay, which is look like a foreign body, which is not similar to the side what is present. On the side a different rock, and in between there is a patch of a different material. So what is that? So that is called as a xenolith. This is called as the xenolith. So what is that xenolith? It is a foreign rock fragment, okay, which is not of this origin, it is something different origin, so we call it as a foreign rock fragment that are included into the magma when it rises up towards the earth's surface. And if they are not digested, okay, if they remain undigested, they remain entrapped within the mass of the igneous rock, and they produce a heterogeneous structure, that is a different structure. So such entrapped fragments of foreign rocks, they are called as xenoliths, and the structure is called as xenolithic structures. So these are all the different structures and their formation by the igneous rock. So the structure shown by igneous rock, again important question. So write a note on different structures which are shown by the igneous rocks. Okay, igneous rock structures, which is very important. So xenolith, I hope you have understood what is mean by xenolith. It is a foreign rock fragment that remains undigested when the magma is rising towards the earth's surface. So that only some parts, some fragments, they remain undigested and they get entrapped within the mass of the igneous rock, and they produce the heterogeneous structure, that is different. This is different and this is different. So it produces a heterogeneous structure, and such entrapped fragments are called as xenoliths, and the structure is called as xenolith structure, or it is also called as xenolithic structure. Xenolithic structure. So these are all the structures shown by igneous rock. So xenolithic is a foreign rock body, okay, which remain entrapped. Then pillow structure, pillow lava, they look like pillows, and this is seen in basaltic rock again, okay, that is mainly basic lava when it comes in contact with the sea water, okay, that exhibits the appearance of small structures which you can compare with the pillows or the cushions, and these pillows have a vesicular crust, okay, and such structures are called as pillow or ellipsoidal structure. Then columnar structure, these are again common structures which are shown by basaltic rocks, okay. So when the magma is having homogeneous composition, okay, when the magma of homogeneous composition, when it starts cooling, what happens, there will be development of centers of contraction at the equal distance, and towards the center the lava starts contracting, and as a result what happens, the parting planes are developed because of the tensile stress which is developed because of the development of cooling centers, and this is how the columnar structure is formed, okay. And blocky and ropey structure, blocky structure is commonly shown by the lava which is acidic in composition, the lava which is highly viscous, which cannot flow for a greater distance. What happens after cooling or solidification, the surface of such lava is covered with the very rough jagged angular blocks of all dimensions, and that is called as the blocky or simply AA structure, and it is characteristic of viscous lava. Whereas the basic lava, that is very mobile, okay, very mobile because it has low viscosity, such lava can flow for a greater distance, and while cooling, what happens, it results into smooth surfaces with highly glazed, and they exhibit wrinkles, and it looks like rope, okay. So it is called as ropey structure. And the one more structure which is shown by igneous rocks is vesicular and amygdaloidal structure. So when the lava it comes on the surface, the gases which are present or the vapors which are present, which are entrapped in the lava, those gases or vapors, they escape, because as the lava comes on the surface, the pressure is diminished, and as a result the gases, they escape and they leave behind the spaces, those are called as voids or vesicles. And these vesicles, when they are formed, they get filled by secondary minerals like calcite, zeolites, and they look like almond. Okay, they resemble the shape of a almond, and hence the secondary structure wherein these vesicles or voids are filled with the secondary minerals, then it is called as the vesicular and amygdaloidal structure. So these are the structures which are shown by igneous rocks. So this is again a very important question from exam point of view. Structures of igneous rocks.